I'm in the picturesque and romantic landscape of the far northwest of Scotland, about 250 miles north or a 5-hour drive from our capital, Edinburgh. Despite the rugged and remote location, tucked away in this corner of Sutherland is perhaps the most visually striking piece of engineering architecture in the country, Kylesku Bridge. The chosen design was a 5-span box deck supported on inclined pier legs. At over 275 metres long, 7.5 metres wide, Kylesku Bridge stands 24 metres above the water. This year the bridge turns 40 and we want to help celebrate its anniversary. The bridge was designed by renowned engineering, design and planning corporation Ove Arup, and built by one of Scotland's leading construction businesses, Morrison Construction.
I spoke with the chief engineer responsible for the bridge's construction, Michael Martin, about the many logistical, design and engineering challenges to build Kylesku Bridge.
The first challenges were really about the basic logistics of construction. How do we get craneage there? What craneage do we need? Bearing in mind we're in a very remote part of Scotland where you couldn't take heavy craneage to that site because you'd end up in a bog. The roads couldn't cope with it. It was then down to the actual physical construction. And I think the real reality of how difficult it was going to be was when I started designing the support work and the shuttering for the bottom of the piers. That was one of the first things that we did. And we called those pieces the crutch. And they are enormous pieces of concrete, massively reinforced, and the problem with them, as with everything on the pier legs, they're unstable. They'll fall over until the whole of the pier is complete. The second challenge is that the legs are actually hollow. The walls are only about 300 millimetres, possibly less than that thick, very heavily reinforced, and so you're working with very, very small margins with complex geometry, which the guys on site did find quite difficult to understand. One of my challenges was to convert the engineers' design drawings into true dimensions so that the joiners and the steel fixtures actually knew what shapes they were trying to build, because they couldn't visualize those shapes just from the drawings that were produced initially.
It won't come as a surprise, given the bridge's exposed location, that Scotland's weather would add another layer of difficulty to the team on the ground to deliver the bridge on time.
We talk about strong winds. I remember one particular occasion where there was a lot on the national news about winds closing, I think, the Severn Bridge, and it was such a big news event because the wind was, I don't know what it was, 100 kilometres an hour. Well, we were getting winds like that all week, every week. We had men blown over on site by the wind. Some days it was impossible to work. On a lot of days it was just extremely difficult and unpleasant to work.
Some delays to the project called on Michael and his team to come up with an ingenious engineering solution to get the programme back on track.
It was a 2-year programme period, and we lost quite a bit of time with the pier legs because of the difficulty of constructing them. But we were very determined to finish the project on time, and so we looked for ways to accelerate. And one of the things that we did was that rather than building the centre part of the bridge in situ, which was the original design, we blasted away a section of the hillside to create a level platform, and we basically prefabricated about 36 metres of the bridge on land. Brought a barge over from Rotterdam, skidded that section out onto a barge, moved it out underneath the bridge, and using a system of hollow-ram jacks, we lifted it up off the barge and up into place. So in an operation that lasted no more than about a week, we were able to get that prefabricated section from the land and into place whereas had we have built it in situ, you would have been talking about months. And I think that was quite fundamental in getting us back on programme and finishing the project on time.
With the work to Kylesku Bridge complete, the task now was to find a dignitary to formally open the new crossing. A stroke of good fortune ensured the opening ceremony would be warmly remembered by the engineers and the local community for years to come.
We were fortunate in some regards that the Queen was having her annual holiday and was touring around the north of Scotland on the Royal Yacht Britannia, and that coincided very nicely with the period shortly after completing the bridge. So she agreed to come and open the bridge, which was a tremendous event, not just for us as the construction and design team, but also for the whole community. It's a very small community up there, so to be able to see the royal family face to face is great. We'd set up a tents with a display, and she was walked around that. I got the opportunity to meet her, which was great. So tremendous, really. You know, one of the things you look back on in your life in engineering and say, well, that was really quite something. When you talk about teams, that was one of the best teams of people that I've ever worked with. And it was a team of people who had different contractual responsibilities and every reason to not work together, but took every opportunity to work together. That's what engineering should be about.
Were it not for Kylesku Bridge having been built at this location and offering a connection across this stretch of water, the alternative would be over 100 miles of a detour. And with an estimated 12 million vehicles having been carried across the bridge over the last 40 years, it's plain to see how the crossing has become instrumental in supporting the local and the national economy, improving connections, shortening journeys, and improving journey time reliability. A testament surely to all of those who were involved in its design and construction.